friends, welcome to CEC live lectures. So in the previous lecture we were talking about time sharing multi-programmed systems. So we will be we were talking about the different types of scheduling algorithms which are used for job scheduling and for CPU scheduling by operating systems in order to use the CPU in the most optimum manner. Now in a time sharing system, as we were discussing, the operating system has to ensure that reasonable response time is also there, because many of these applications, they are critical, mission critical applications, and there it cannot wait for too long. So this goal of providing a response within a specific time, this goal is also accomplished through swapping, whereby processes are swapped in and out of memory to the disk. A more common method for ensuring reasonable response time is virtual memory. Now virtual memory is a very interesting technique that allows the execution of a process that is not completely in the memory. That is, virtual memory is basically a type of memory which is actually the disk which is acting as the random access memory or the main memory. So the main advantage of the virtual memory scheme is that it enables users to run programs that are larger than the actual physical memory. So if a program requires more space than the actual memory, so then this concept of virtual memory comes into picture. So it is actually an abstraction of the main memory into large uniform array of storage, separating logical memory as viewed by the user from physical memory. So virtual memory is a concept of logical memory, and this frees the programmers from the concern of memory storage limitations, because virtual memory can be practically much larger than the actual memory, because what we are saying is that a portion of the disk, of the hard disk, is behaving or is said to be behaving as the main memory. Right. So it provides a larger storage area where bigger programs which are actually larger than the memory can also be stored. So basically all these mechanisms are done so as to give the user the most convenient and the most efficient use of the computer system. Now if we look at different ways in which operating systems work, or what are the operations of the operating system. So basically there is one concept which we talk about in operating system, that is known as the concept of interrupts. So interrupt driven hardware, it could be hardware driven interrupt or it could be software driven interrupt. So hardware interrupts by one of the devices, that is one of the devices interrupts the process, or a software interrupt could be an exception or it could be a trap. So exception means that it could be a software error. Say for example, there is a logical error in a program where a user is trying to divide something by 0, okay, or there is a request for operating system service. Other process problems can also be there, like for example there is a problem of infinite loop in a particular program. So what are these? These are all examples of different types of exceptions which can occur, and these exceptions are then later on going to behave like software interrupts. So these are also known as software driven interrupts. So processes, they are modifying each other or the operating system. So there are certain operating systems which work on the dual mode. So dual mode operations will allow operating system to protect itself and other system components. And there is another mode which is this, in dual mode we have basically two modes. One is the user mode and the other is the kernel mode. So in mode bit provided by the hardware, so it provides the ability to distinguish between system running user code or running the kernel code. Kernel is nothing, kernel is the inner core or the main code of the operating system. So some instructions which are designated as privileged instruction, they are only executable in the kernel mode, they are not executable in the user mode. There are some system calls which we can make change to the kernel, or they can change the mode to kernel. They return from call resets to user mode. So increasingly CPUs they support multiple mode. virtual machine manager or the VMM mode is also used, which it is used for the guest. So these are the different modes. You can use the operating system in the kernel mode, you can use it in the user mode, then you can have various kinds of virtual machine manager modes also, which are used for guest virtual machines. So basically, when an operating system is performing multiple types of functions, as we have already discussed, and each of this function is very, very critical to the overall performance of the system. So now we are going to look at individual functions of the operating system very briefly, very broadly, and later in our discussion we will go in the in-depth discussion. So we are going to look at how process management is done, how memory management is done, and how storage management is taken care of by an operating system. So basically, in case of process management, first and foremost, it's very important to understand the difference between the term process and the term program. So a program does nothing, unless its instructions are executed by a CPU. So a program in execution is a process. If you are looking at a time shared user program, such as a compiler, so compiler is a process. A word processing program which is being run by an individual user is a process. A system task that is sending output to the printer, it can also be called as a process. So a process basically it is nothing but a program which is being executed at a particular time. So a program is basically you can say that a program is an inactive or static entity, whereas a process is an active entity. So a process needs certain resources. Like what are the resources? It will need CPU time, it will need memory, it will need some files, IO devices, etc. to accomplish its task. Now these resources are given to the process when it is created or allocated to it while it is running. So there are different again for this also there are different algorithms. That is, a process can have a configuration that it will only start when it has already taken up all resources, or a process can start and as and when it requires certain resource, if it requires certain memory space or if it requires certain IO, then it will take it and it will abandon it. So there can be different ways in which different operating systems will implement this strategy. So in addition to the various physical and logical resources that a process may obtain when it is created, there is also some initialization data which may be passed along. Initialization data means that input data which the process needs to start actually. So for example, if we take a process whose function is to display the status of a file on the screen of a terminal. So now the process has to be, it will be given the name of the file as an input, and it will execute the appropriate instructions and system calls to obtain and then display the desired information on the terminal. And when this process will terminate, the operating system will reclaim any reusable resources. So once the system file has been displayed, then of course the operating system will reclaim the control of the terminal from the particular process which is trying to display that file. So a program by itself is not a process. So as we already said that a program is not an active entity, it is a passive entity, and like the contents of a file stored on a disk, whereas a process is an active entity which is under execution in the CPU. So a single threaded process has one program counter which is specifying the next instruction to be executed. The execution of a single threaded process is going to be sequential, and every time one instruction is executed, the program counter will increase to 1 because it is 1, 2, 3, 4. It's a sequential order in which the execution is going to take place. The CPU will execute one instruction of the process after another until the complete process has finished. Further, at any time, one instruction at most is executed on behalf of the process. So for one particular process, only one instruction will be executed, and the flow of sequence, the flow of instruction execution will be sequential. Thus, although you can have two processes may be associated with the same program, they are considered as two separate execution sequences. If one single program can have n number of processes, because and every process will have its own execution sequence. So, a multi-threaded process has multiple program counter, and each program counter will point to the next instruction in the given thread. So, for every process there will be a new thread which is going to be running, and for every instruction or for every process there will be a separate program counter. So, it is basically a unit of work in a system. So, program is not the unit of work. A program can be further divided into processes, and every process is the unit of work in the system. So, a system consists of a collection of processes, some of which are operating system processes and the rest of are user processes. So, operating system processes, they are generally known as system calls or system commands, which are being run by the operating system, and user processes can be any of the application processes which are running. So, all these processes can potentially execute concurrently by multiplexing on a single CPU. So, we understand that this is possible in a multi-programming environment. There can be n number of programs which can open, and for every program there can be n number of processes which are taking place. So, operating system is responsible for the following activities in connection with the process management. So, when we are looking at process management, what are the important functions which the operating system performs? First is that it is scheduling processes and threads on the CPU. We have already discussed what is scheduling. Scheduling means assigning the processes in what particular order to the CPU for execution, creating and deleting both user and system processes, suspending and resuming processes, providing mechanisms for process synchronization, and providing mechanisms for process communication. So, these are the main functions of an operating system with regard to process management when process management is concerned. The next important function of the operating system is the memory management. Now, we all understand that main memory or the RAM, what we call as, it is a large array of bytes, and it can range in size from hundreds to thousands to even billions, right. We know that memory space is almost now becoming, it is growing exponentially, and memory is becoming much cheaper also, and each byte will have its own address. So, main memory is a repository of quickly accessible data which is shared by the CPU and the IO devices. All data exchange between to and from the CPU will occur only through the main memory. So, the CPU, it reads instructions from the main memory during the instruction fetch cycle. We've done different cycles of CPU. So, in this process of CPU should how the CPU functions. So, instruction fetch operation is there, and the CPU will read the contents of the main memory to read what the next instruction is. Both reads and writes data from the main memory during the data fetch cycle. So, in instruction fetch cycle will read the instruction from the memory. In data fetch cycle, it will fetch data from the main memory, or it will write back data to the main memory. So, the main memory is generally the only large storage device that the CPU is able to address and access directly. It does not access the secondary storage or the disk directly. So, if for example, the CPU is to process data from the disk, so that data has to be transferred to the main memory, and this is done by using CPU generated IO call. So, IO call, these are not the input output call, but these are CPU generated calls in which the CPU will call for data from the disk to the main memory. So for a program to be executed, it has to be mapped to absolute address and loaded into the memory. So as the program will execute, it accesses the program instructions and data from the memory by generating these absolute addresses. So absolute address is actually the address of the data on the disk. Eventually the program terminates, its memory space is declared available and the next program can be loaded and executed. So when a program is under execution, it has to reside in the main memory. After the program's execution is over, the program is unloaded and a new program is brought into the main memory. So to improve the utilization of the CPU and the speed of the computer's response to its users, general purpose computers, they must keep several programs in the memory, and therefore there is a need for memory management. The memory is to be managed. Why? Because multiple programs will reside in the main memory of the system. So management scheme, various management schemes can be used for main memory management. These schemes reflect various approaches, and the effectiveness of any given algorithm will depend on the situation. So again, for memory management also, there are multiple algorithms which we will look at in later lectures, that what are the different algorithms and which algorithm will we use, it will depend upon the particular situation. So in selecting a memory management scheme for a specific system, we must take into account many factors, especially the hardware design of the system. So what algorithm is to be used is a very critical decision which needs to be taken after due reflection upon the hardware design. Each algorithm will require its own hardware support. The operating system is responsible for multiple things, when you are talking about memory management. The first and foremost is keeping track of which parts of memory are currently being used and who is using them. Then it also, the operating system has to decide which processes or parts of processes and data to move into and out of the memory. So how the data is to be swapped from the memory, swapped in or swapped out, and allocating and deallocating memory space as needed, because we know that there is a constant competition for memory space amongst the processes. So it is important that allocation, deallocation of the space happens at a very, very fast pace. So for this, now in connection to the main memory or the memory management, we have another aspect, that is storage management. Now what is storage management? This is basically, to make the computer system convenient for the users, the operating system provides a uniform logical view of information storage. So the operating system, it abstracts the physical properties of its storage devices to define a logical storage unit, that is the file. Now a file is basically one unit of storage which is defined by the operating system. Operating system will map the files onto physical media and accesses these files via storage devices. So file management is one of the most visible components of an operating system. Computers, they can also store information on several different types of physical media. Like we all know, there are magnetic disks, tape, optical disks, etc., which are used. And each of these media, it has its own characteristics, whether it's physical characteristics or physical organization, like type of medium, magnetic, electric, optical. Right, how this is controlled, that is, the device driver for each, whether it is a tape driver, it's a disk driver, it is a DVD driver, different types of memory. So every device is different, and the mechanism of every device, the characteristics of every device are also different. So all these properties will include access speed, the capacity, how much data can be held, the transfer rate at which the data transfer is going to take place, and the access method, whether the access data will be accessed sequentially or it can be accessed randomly. All these points are very important when a decision related to the file system is made by the operating system. So a file is nothing, it is also many a times called that a file is a collection of records, or it's a collection of related information which is defined by the creator. And commonly files, they represent program. Now program could be source program, or it could be an object program, and of course the data. Data files, they can be numeric, they can be alphabetic, alphanumeric or binary, and files may be free form, like for example text files in which any type of data can be stored, or they can be formatted very rigidly, which are known as the fixed fields files. So operating system, it implements the abstract concept of a file by managing the mass storage media. Mass storage media means we are talking about the tapes and the disks, and besides these you also have certain devices or the drives which control these mass storage media. So in addition, files are normally organized onto directories to make them easier to use. We all have done this. We have certain files and those files are put in folders. So the similar analogy can be used here. So we have records, records are arranged into files, and the files are then arranged into folders or directories. So finally, when multiple users have access to files, it may be desirable to control which user may access a file and how that user may access it. So because there is a problem of concurrency. When multiple people or multiple processes are trying to make changes to a file or trying to read a file, right, or make append data into a file, so then concurrency control mechanisms are to be put in place. This is also done by the operating system. So the operating system is also responsible for creating of files, for deleting of files, creating and deleting of directories or the folders which are used to organize the files, supporting primitives for manipulating the files and directories, and mapping files into secondary storage, backing up files on stable non-volatile storage media. So multiple facets, multiple aspects related to file creation, file management are taken care of by the operating system. So if we talk about the mass storage management means, because we understand that the main memory is much small and therefore it cannot accommodate all data and programs, because the data it holds are lost when the power is lost. We have discussed this, that all main memory, whether it is RAM or it is cache, these are electronic and they are small in size. So the computer always has a secondary storage to back up the main memory. So now most of the computers, they are using disk as the principal online storage medium for both programs as well as data. So most programs, including compilers, assemblers, word processors, editors, formatters, they are all stored on a disk until they are loaded into the memory. So they reside on the disk and then use the disk as both the source and the destination of their processing. So for proper management of disk storage, it's also very, very important to a computer system, because the disk is actual place where the data is going to be stored. It is the source of the data, as well as after processing it is the destination of the data. So operating system is responsible for different aspects related to disk management, like freeing the space management, storage allocation and disk scheduling, because secondary storage is used more frequently, therefore it has to be used more efficiently. The space, although we say it's a mass storage space, but still more often than not we see that we are struggling for secondary storage on our computer system, and the entire speed of operation of a computer will hinge on the speed of the disk subsystem and the algorithms that manipulate this subsystem, because eventually it is the disk from which the data is originating, it's the disk from which the data is being transferred. So if your disk is a slow disk, then definitely the entire performance of the system is going to come down. So there are many uses for storage that are slower and lower in cost, right, and they are also in high capacity than secondary storage. backup of disk data storage of seldom used data, and long term archival storage of data are also some of the examples. Besides this, magnetic tapes are used, CD, DVD drives are used. There are platters, disk platters which are also very commonly used these days. They are also used as typical tertiary devices. So, the media, whether it is tape or it is optical platters, they can be used like, they can be write once, read many times, or they can be read write format. So, tertiary storage is not crucial, but it is also to be managed. So, this was about today's lecture, that is we talked about process management, memory management and storage management. We shall be continuing with more such insightful topics. Till then, please keep watching CEC. Thank you.